Okay, welcome everybody to our monthly webinar. My name is Jackie Jacob. I am one of two extension specialists here at the University of Kentucky. As part of my job, I coordinate the community of practice for e-extension, which is the electronic version of the cooperative extension service. And we have a group that is specific for small and backyard flocks. And for several years now, we have been doing these monthly webinars. They are all recorded. This one is being recorded. They're posted online. I will post in the chat box the links so you can find the past webinars as well as upcoming webinars. And if you have any topics that you would like to see, you can always email me the topic of your choice that you would like to see discussed. So this month's webinar, we got one from San Antonio, Texas, small mixed flock, mostly bantams. Okay, cool. If anybody else would like to let us know that, that's always good. Our speaker today is Dr. Morgan Hayes. She's also at the University of Kentucky. She's an engineer, and she's going to be talking about repurposing buildings for poultry. If you have a question at any time, you can type it in the chat box, or you can type it in the Q&A box. If the question is a clarification of something that she's talking about at that time, I will pop up and interrupt her to get clarification. Otherwise, the question will be held until the end. So if you're like me, you forget what you were going to say if you don't write it down right away. So if you think of a question, feel free to type it in the chat box or in the Q&A box, and I'll keep an eye on that. So it's all yours, Morgan, if you would like to share your PowerPoint. Okay, I'm going to be on mute.
Okay, so I was tasked with repurposing existing structures for poultry production. I am by nature an engineer. I am trained in livestock facilities, and in fact, I did most of my PhD work on aviaries and alternative style laying hen operations. So that's probably where I have more familiarity, although I now live in a state with lots of small flock meat birds as well, which is kind of interesting to see all the different structures that are getting used for poultry production. I wanted today to sort of split the talk into two parts. I want to talk about structural basics and some structural considerations for using and repurposing a structure that was an existing poultry barn to make it house birds. And then I want to talk about ventilation basics and some ventilation considerations that come in with these barns as well, because I think those are two of the major challenges that really focus more on the engineering side rather than on the management side of repurposing a structure. There are certainly other challenges, manure management, some other things like that, that are not to be dismissed. But I think these two really cover sort of generally the bigger issues with putting animals into buildings that weren't actually intended for them. So let me just start with some structural basics. The way that a wood structure works, which is most facilities that house animals, a lot of times we're talking about older sheds or buildings like that. The basis of the structure is the post or the column. The vertical members that you see here in these images carry weight from any of the building materials or any internal load that's put on top of them, as well as any roofing materials and any snow or rain or ice or wind that pushes on that building. So these members that go in the vertical direction are sort of the lifeblood of the building. That's what actually moves all of that load from that building into the ground, into the soil structure where it's handled. Typically, in our smaller buildings that we see being retrofitted, we're looking for something like a rafter or a truss to hold up the roof. And then from that, we have what's known as a top plate on our side walls of our building. And those plates are typically on either the outside or the inside, or both, depending on the size of the building and the spacing between posts. And those plates basically carry the load from anything at the top, from the roof line over, so that the column can take that load downward. And then on the sides of our buildings, we have a couple other components that are really important. Those plates I just mentioned that are at the top. And then we have usually studs in our walls that give our building structure. And then we have what's known as a header board. And a header board is there specifically to make an opening so that all that weight that's coming down in the studs gets pushed to the side, and there's enough structural member in the vertical direction to carry that load or weight. And those header boards are really important to get correct, to make sure that nothing gets sags or doesn't hold up over time. And then at the bottom, there's typically a sole plate, and a plate at the bottom is there to keep everything square and usually to attach it to whatever foundation is there. This is one of those materials that struggles quite often under manure or litter, however you want to describe it. It's a pretty tough material for a lot of barns because this piece in particular can be very susceptible to degradation due to that. So a lot of times we need to protect that member when we bring animals into a space. And this is just another picture here of top plates with, in this case, trusses, but trusses or rafters being attached to them. And what you see underneath there is actually a header board. So this is a larger barn that's going to have a sliding door on it. But this is essentially a header board that we're going to be able to mount our hardware to put a door onto. And this board is only there to handle the weight of the door and to make sure that that load gets onto our columns the way we want it to. The other part of the structure that we see pretty commonly, and you'll see this a lot of times on the inside of these sheds, is not only do they have rafters which go along the line of the roof, but there's also a member that's horizontal across, and it's known as a joist. And the joist is there for a couple reasons. The primary one is not to hang electrical equipment, although it is used for that fairly often. It's there to square up the structure and potentially to provide extra support at the top of the roof. In this case, they're using it to create a vertical post right there in the center to further support that roof under heavier snow loads. So we see this design a lot of times in older wood structures that are getting retrofitted, making sure that these joists are secure, well nailed together, and not twisting is a pretty good indication that a structure is sound and hasn't started to degrade, or that the foundation isn't starting to fail underneath it. The other major component to a structure is the sheathing or siding on the structure. And the sheathing and siding is the material that gets placed around the outside of the wood, the columns, if it's done in a wood stud design, to keep everything square. The sheathing and siding also takes wind loads and other loads on the sides of the building, and it moves that load around so that it displaces it evenly across the whole side of the building. So not one member has to take all the load. This is another thing that sometimes we struggle with when we move animals into buildings that weren't designed, is we want to create openings for ventilation, and we'll talk a little bit about that in a minute. But a lot of times we cut out parts of our sheathing, and if we're not careful, we can actually create some structural instability by creating openings that are too large, that aren't properly framed in, and it does create some extra movement in the building that isn't supposed to be there. And then, of course, the one thing we do want to have is those windows and openings. And it is really important, especially as we have animals and chickens in these spaces, other poultry, that we create large enough openings for airflow and for animals to enter and exit. the barn or the shed or whatever the building was originally purposed as. But we want to make sure that those are properly sized and they do have the right structural members around them so that those doors that open and close can swing freely the way they need to. And last but not least, all of that structure then has to go into the ground or into a foundation. And this picture is a perfect example of a very nice shed that still looks to be very square on a very questionable foundation here, which is not unusual. So what they've done is they've basically put blocks right on top of the topsoil. And then they've basically braced it to get everything squared up with some smaller pieces of wood, which are probably runner boards, which was used to slide that shed off of whatever trailer hauled it in and onto these concrete blocks. One, the concrete blocks may or may not be structurally sound in the sense that they may not hold the whole load of that building, depending on what's in it. But the other thing to consider is that this foundation is not very square to the building or to the ground itself. If we're putting in a building like this or retrofitting it, we want to make sure we have a nice level surface underneath there and that we attach it to the ground, typically below the topsoil. In our area here in Kentucky, we have a lot of clay base. For some areas of the country, they're digging down to a rock base, but you're trying to dig down under the topsoil, which is usually a very soft material that moves freely to a more stable material that can be compacted and be very stable over time and won't move underneath that structure, creating a lot of instability there. And ultimately, what we're trying to avoid is collapse on these buildings. That's the reason to make all these decisions. It's the reason that we should be looking at the building before we start retrofitting it to make sure it is structurally sound. So we want to make sure we spend the time before we start spending money making it work for an animal to make sure all those other structural components are good, because it's very frustrating to invest in retrofitting a building, even if it was free, to only have it last for a year or two because the building really wasn't sound to begin with. A couple specific considerations about the structures of these facilities. I just want to take a couple images here and just highlight some things that I think are considerations that need to be made. This is a small hutch that someone basically built out of an old box. And the animals aren't really intended to spend a lot of time other than at night in this little structure here. Things that do need to be considered, though, is that this building right here, one, is not going to be easy to clean necessarily, but two, it's right on the ground and there's not a lot of protection for this from a foundational standpoint. There's nothing to keep this from deteriorating. And you can see that a lot of the wood material at the base of this looks to be in fairly poor condition. Similarly, on the roof line here, it's a wood structure with a wood roof, and wood doesn't necessarily shed water well, especially if it's already deteriorating and there's already a lot of pockets and holes for water to sit in. This is an interesting structure. It's an old dog house that someone is utilizing for poultry. And this is a pretty creative solution here. They've taken an old dog house. They've changed the door style. Instead of hinging at the top, it hinges at the bottom here. And then they have a ladder basically allowing the animals to climb up and down. There are a couple things to note, though. The structure originally had its vertical member right here at the corner of the structure. And instead, they've put this other metal frame underneath it. And the metal frame is really a good idea for a couple reasons. One, they have some area at the bottom to let manure out and they can clean it up more easily. Two, this metal structure is actually intact in the ground. These are sunk in the ground. If you look at the larger picture. And then also they've put what's known as a 4x4 or a larger piece of lumber at repeated measures along the length of that dog house to shore up the base. So basically, instead of forcing this one member to carry all the load by putting these wood members underneath other vertical members on the side of the building, they are supporting that building where all those vertical members come down. So each vertical member can then attach into this frame, this metal frame that's built to carry that load back down there. What I see sometimes people do is that they'll choose a structure like this and attach the four corners, but they won't put support all the way along the walls, so that each time there's a vertical member that's taking a load, that there's something underneath it to receive that load and move it to the next member down. Because what we've essentially done here with this structure is we've taken what was the original floor and put new floor joists underneath that floor and created another level to the structure. And when we do things like that, we do want to be careful to make sure that the new lower level that we're adding does have the capacity to hold all of the member above it, plus all the birds that are inside the structure, plus any manure that's in the structure, plus any snow or wind that might be building up on the top, which can be a significant amount of weight. And even though the doghouse itself might not seem too heavy, if you're able to pick it up yourself, by the time we add in manure and bedding, and if we have water or feed inside there, all of those things, the weight will add up quickly, and it should be accounted for when creating that new base underneath them. One of the other things that does I see quite a bit, and I think is an interesting option, is if you have an existing structure, adding a lean-to onto it. One of the things I would say is that adding a lean-to onto an existing shed or structure is a pretty good strategy for creating more space structurally. But there are some considerations. Typically what happens is that this second roof line gets attached with some form of a joist hanger to the existing plates. You want to be careful if this happens, that there is enough member in the plates here at the top of the existing shed to take the load of this new roof. And just because you can buy a 2x4 that's 16 or 18 or 20 feet long does not necessarily mean you want to run a member that long without vertical support in the center. It will bow and it won't hold up over long term. So you want to choose the right size lumber if you're going to create larger sheds like this with pretty significant areas. Not only do you need enough support on this column in the original shed, but you also need structural lumber to run along this shed roof line, this rafter here, to handle the total length of this, including the metal, any purlins that are there to nail to, and any load like snow that might exist in some locations. I will say that this one nice thing about this design is they have actually put a gutter there and they've moved the gutter away, which does create a benefit from a water standpoint. We do get water away from this area, and having water run into our sheds and other structures like this makes manure management a lot more difficult. So that is one really nice benefit of this design and layout. This is another example of a lean-to here that I think is really well thought out. This is a much smaller lean-to. I feel more comfortable with this from an engineering perspective when I look at this image. This is a lot less weight that we're putting on this side of the building. And you can see here that there are 4x4 columns here, if you look at this image pretty carefully, and all of those also provide some structural stability here on the outside. Also that they've created opening here at the bottom for ventilation, but they've created some siding or sheathing up here at the top to create some structural stability if there was any wind or twisting motion, to keep all of this squared up in the long term, which is really nice to see. The one, there's a few things that we add in poultry buildings that add weight to the structure, and we always have the option about how we install them, but it is a consideration, and one of them is perches. A lot of times people will add perches to a space by leaning something up against a wall of a building. In this case, this is what's known as a nailer board. On a roof line, it would be known as a purlin. Some people will call it a girt, which is a more common term used on a metal structure. But it's essentially here to keep everything square and to allow us to nail our siding to it. These boards are not necessarily designed to take a vertical load downward though. And so adding things like a perch to this adds additional weight and can bow this out, which can create situations where the siding pops off from this because the board itself is moving and the nails that are holding the siding on just sort of pop away due to the basically torque on the nail. So we want to be careful about how we assemble a perch and place it into the building. This could easily be solved if we had created a second member and created a triangle and created perches on both sides of it and have it stand freely, standing alone, not necessarily attached to the side of the building. Realistically, one this size with this number of birds is probably not going to create an issue. But you can see here another couple examples of birds perching. The general recommendation, at least for laying birds, laying hens, is around 8 inches per bird. For a 3.5 pound bird or something in that ballpark. And realistically, even though we say 8 inches per bird, I know how birds like to pile up. I think realistically, you could have 2 or even 2.5 or 3 birds within a foot if they chose to really huddle for warmth at night. And that would mean you're looking at something in the neighborhood of 7 or even 10 pounds per foot of perch space. So getting that perch so that it's not tied to the wrong members and instead either stands alone or has some structural support underneath it might be critical for the long-term structural stability of the building. Nest boxes are another thing that can be quite heavy, and not necessarily because of the animal density or the eggs. There can be some manure buildup in there, although that also doesn't tend to be hugely problematic. But actually, because of the design and build of them, a lot of times they're built out of heavier materials. In this case, it's a plywood that's a little bit over it's about a 1/2 inch thick, which is not a lightweight material. So by the time that people have installed a number of nest boxes up on the wall, depending on how that was built, that could be pretty cumbersome for some of those structural members to hold. If we have a lot of vertical columns and things like that we can attach to, it's less of a problem. If we're attaching it directly to siding or other thinner materials like that, it can be more problematic and can work its way loose over time. So making sure that those nest boxes are either mounted to some well-designed larger structural members, the columns or posts, or that they're at least somewhat supported in the front to make sure they don't pull downward and away from those walls is really a good idea from a structural perspective. And last but not least, I believe this is my last structural consideration here, would be hanging feed and water lines in these spaces. In particular, I think a lot of times people discount the weight that they're attaching and how they're attaching it to joists on the ceilings or other members. A lot of times we have options, but if we can create any sort of hanging feed structures so that they're not all hanging on one joist, but hanging on different joists, that is ideal. That way we don't have one member carrying all the weight, but we have different structural members carrying smaller amounts of weight. When buildings get designed, there is an internal load that we assume is available for hanging things, but it doesn't necessarily assume that we're going to hang 30 pounds of feed in 4 different spots on one joist. That's maybe an unrealistic expectation when someone designs or builds a shed. That wouldn't be what they would expect to see. And similarly, water lines are typically not too bad as long as we're using smaller PVC lines. but I have seen people put in heavier water drinkers that do like these bell waterers. And depending on how they have them set up, they can also create pretty significant amounts of weight in one spot versus nipple drinkers, which tend to create a pretty balanced weight across the floor space. My last consideration, I lied to you folks, is openings for ventilation. Generally, I want more openings for ventilation. I'm a proponent of them, but from a structural perspective, you want to be careful about cutting openings into a wall and not reinforcing those openings. This existing door clearly had a header over it. This one also was well done. There is actually a header there that's holding this, and then it's just tied up to the ceiling there. But you do want to be careful if you're cutting openings to create airflow, that you do reinforce them with some form of a structural header and a stud board at the bottom as well. Basically so that opening is reinforced so that the loads do travel around it the way they need to. And I want to just jump a little bit over to the ventilation basics here. If there's any structural questions, I'm happy to handle them at any point here.
No questions have come in so far.
Perfect. So let's go into ventilation. Two types of ventilation that really exist. One is known as natural ventilation and the other is mechanical. And natural ventilation basically assumes that we take advantage of normal air movement to get air exchanges in the space. And the purpose of ventilation is to provide fresh air for the chickens or other poultry, and to remove any stale air or ammonia, dust, any moisture buildup in the barn or shed. And we want that to happen sort of on a continuous basis. In the wintertime, when it's very cold out, we want to have the minimum amount we need to get that moisture and stale air out. In the summertime, we want to push as much air through the space as we can to keep it as cool as possible, because all those birds are continuously pushing out heat just by nature of their metabolism and their movements and all of that. And we just want to move as much of that heat out of the barn as possible so the barn is as cool as it can be. So that's always our goal. Natural is typically my goal when I'm making recommendations to people for a couple of reasons. With a good design, it sort of does its own work. The other benefit is I don't have to pay for electricity. If I have to move to a mechanical system or a ventilation system that utilizes fans, then I am responsible for paying for the electricity to ventilate the space, which is not necessarily a deal breaker, but it also requires running ventilation to the barn or shed or whatever facility is being retrofitted, which in some cases is very easy and in other cases is very difficult to do. There are two types of natural ventilation: buoyancy and wind-driven. Buoyancy is our primary ventilation concept that we want to have happening in the wintertime. It's our goal in the wintertime for getting our minimum amount of air to get rid of all of our stale conditions. And it's basically controlled by temperature difference. So there's got to be some heat in the barn due to the animals being in there. So anytime the chickens are in there, they're creating heat in the space, and that heat in combination with any moisture, dust, pathogens, ammonia that's down here where the animals are is going to rise. And then that stale air is going to make it out of the top of the barn or shed or whatever structure we're looking at. And any fresh air in theory comes in through an eave or a small sidewall opening, a pop out, something like that. The area of the inlet and the area of the outlet are strongly related. That means we need to have enough opening at the ridge or at the top of the roof line to equal the amount of opening we have on the sidewall. Otherwise, it chokes how much air is going through, or we create drafts on the sidewalls that we don't necessarily want. The other thing that is worth noting is that the speed at which air is able to escape is driven by how high the difference is between the inlet where air comes in and the outlet where air goes out. So we will get more air movement if our openings are lower to the ground than we will if our openings are up at the eave. We also have some drafting effects that tend to happen though if our openings are very close to the ground. So it's a little bit of a trade-off that we have to recognize. In the summertime, we're looking to make really big openings in our buildings, ideally, so that the wind can go across the building. So we need to make sure we have openings, inlets on one side and outlets on the other side, and that our air can move across that building. This only really works if we get our barn set up to receive wind. So if we make really big openings over on this side of the building where air doesn't flow and not much opening over here, we can't ever bring air in. We're going to very much control it by our inlet area. It's going to be our choke point. Similarly, if we don't ever create an opening on this side, even if we bring fresh air in, it will slow down very quickly and we won't get the air exchange we want because it will choke at the outlet. And if we only create openings on this other end wall and the air is blowing this direction, we won't get any air exchange at all. So we really have to orient the building to take the wind as it flows near our houses. And sometimes it's really hard with a retrofit to get ventilation to work well. So while I don't generally recommend that people jump to putting in a lot of fans right away, if the retrofit isn't ventilating well, we do have the option of doing what's known as a hybrid system. So if we can take wind well and we have got like good shed doors on two sides of our buildings, and in the summertime we can open them up and get great airflow through the building. But in the wintertime, it's very stale, there's lots of ammonia and we're having some issues. We can use winter mechanical, a small fan that we put on a timer or turn on a couple times a day to get a full air exchange out. And we can just run that fan intermittently. Or vice versa, if the barn does okay in the wintertime, but it gets really, really hot in the summertime, we have the option of putting mechanical ventilation in there to really move a lot of air in the summertime, but allowing natural ventilation through buoyancy to do what it needs to do in the wintertime condition. And for those of us that are in the more southern climates, we're probably managing temperature year round, although it's harder to do in the summertime. And there we might even do something like adding mixing fans to create airspeed inside the barn. We're getting enough air exchange. It's not necessarily that the barn is has bad air quality, although it could be dusty. It might just be that it needs a little more airspeed to cool those chickens down. And we do have the option of putting a fan within the space, not necessarily exchanging air and getting fresh air in, but just creating airspeed blowing on those chickens or on those feathers to allow a little more heat dissipation. So a lot of different things that we can consider doing if the ventilation isn't working, but all of these require us adding fans and having electrical in that space, which is not necessarily our primary goal. That's one reason to think about some things we can do in the initial work on the building. Specific considerations here. A lot of times people will have an older building that was completely enclosed. It was supposed to be a shed to house tools and equipment like that. Other times they'll have one that was used for some other purpose, and there won't be any opening up in the ridge. And they'll say, what do I do now? And there's a couple things that are available on the market that could be used to create airflow. One of them is what's known as a ridge vent. This is a residential style ridge vent right here. What essentially happens is that ridge cap material is just raised up slightly and it's a perforated opening on the side. So it basically gets nailed down instead of a metal ridge cap that gets nailed firmly down. And it just has small openings, only an inch or two, probably about an inch on both sides, to allow a little bit of air and moisture out of the top ridge. Depending on the number of animals, this might still be undersized and less than you need, but it might help if you have a smaller space or fairly limited number of animals, or you're not stocking at a very high density in that barn or shed. You also have these ones that are more commercial, but they're pre-purchased things that you can put right into your ridge opening. They sort of pop onto the top of the roof line. You cut a section of your ridge cap out and you place this in place of it. They work extremely well. They have a known air exchange rate. So we can figure out, an engineer can help you figure out, or an extension specialist can help you figure out for the number of animals, what amount of air change this is going to give you. And therefore you can sort of figure out if it's enough capacity or how many of those you would need along a roof line. And last but not least, this is a cupola design. Here in Kentucky, we have these everywhere. The horse barns have made them sort of synonymous with this region. But cupolas are by nature designed to ventilate. They're basically creating this little chimney, and these can be both for visual reasons, but also they can be open. These can be sort of louvered openings here that don't allow rain in, but do allow air out. And that is a benefit for getting some opening at that top of the roof line. You will want to find one that's not too heavy if this wasn't originally in the design, to make sure it's not putting too much load on your rafters. But depending on your rafter spacing, this is also an option that you can install fairly easily. Another specific consideration, this is more a consideration for winter conditions in colder climates. On barns that do naturally ventilate fairly well, you can see that they would have pretty large openings on both sidewalls to allow air across. If we had very cold conditions, we can use things like nest boxes and insulate behind them to create a windbreak on that windward wall so that we don't have a lot of drafting under those cold conditions. These barns aren't ever going to heat well. They're not designed to be particularly warm. There are some things we can do to make them better, but adding something to stop wind from leaking in on this windward wall is not a bad strategy. And similarly, you can see that they've created some structure here behind these nest boxes to fully support that nest box, not depending exclusively on the posts and the hoop structure itself for holding these nest boxes up, which is a good plan. One other consideration here I have for just a comment here for folks is that if you have a lot of movable structures like this, and you're using them for birds, older hoops that are being used for birds, the locating of movable sheds is also something that's a pretty good idea. Creating movable sheds does two things. It provides an opportunity for choosing the location based upon the weather that's coming. What I'm suggesting here is we can't necessarily enclose in the sides particularly easily, but what we can do is we can choose locations where there are trees or shrubbery or other windbreaks, and placing it in such a way that that actually provides some protection from the most aggressive winds, because these structures are not tied down, and from a structural perspective, sometimes can struggle with more difficult weather patterns. So we do want to take advantage, if we do have some natural windbreaks and things like that, to utilize them as we know weather is coming. That is an option and something to consider. At the same time, we don't want to put it in low ground, obviously, where there's going to be flooding or other issues like that. But there are things that we could do from a locating perspective to maybe help with these more movable structures. The other things I just want to touch on briefly here are managing inlets. From a ventilation standpoint, pop-outs, openings on the sidewall can be really challenging. And especially as we get to smaller structures where we have large doors as our only option, we can have pretty large inlet openings that aren't necessarily our goal, but they're what was existing. And so sometimes we have to rethink these openings, or see if we can open only a portion of them, especially in cold weather, so that we don't have such cold weather inside our shed or barn. Similarly, this is a nice small shed for these animals to be in, but because it's completely open, it has great ventilation for warm conditions, but struggles perhaps if we have very cold conditions. There's no way to close down the opening on this structure and managing that inlet area. We also do have the option of adding some insulation in our more extreme, both summer and winter climates. And adding insulation along the roof line can really help us with our solar load in the summertime if we have heat in our barns or our sheds. We do have to recognize that adding insulation just creates something that birds and other animals like to destroy. So I'm not suggesting that this is an easy thing to do. I understand how challenging it can be to maintain insulation in a space. We usually have to protect it with some other form of a sheathing on the inside of it, or accept that there is going to be deterioration over time. But having insulation on the roof line will really help with summer heat load, and having insulation on walls that would otherwise take a lot of wind load can provide some protection in the wintertime under cold conditions. And with that, I will take any questions.
We have a couple. Tanya wants to know, are shed row roof design better or worse than gambrel or airflow?
I would assume when you say shed row, you mean it's a singular roof line with posts on both sides. In our area, we would set a shed row like that up typically to receive wind on that taller open side, which is our south face. And then that north side would be narrower. And then for gambrel, it would be sort of almost like a gabled roof would be a triangle, but a gambrel would be a triangle with a secondary level on both sides. And so it's going to depend a little bit on how it's set up. If I have a shed row style building, I want to have a small amount of opening at the top on the shorter side. And then I also want to make sure I have an opening at the top of the roof line on the larger opening side at all points. Because what I want is that when airflow comes in, that warm air rises and it can work its way up that roof line and make it out on that taller opening sidewall. Some people will drop a curtain on that tall side to try and take wind out of the space, and that creates problems because then it locks all that moisture and heat up at that top corner and we end up with problems. In general, a shed row style brings in a lot of ventilation. So for summer conditions, it ventilates extremely well, which is really nice. And we can get really good airflow across a shed row, as long as we have some opening on that smaller side to allow the air out. That's really important. For the gambrel style, what we get is a really nice tall roof structure. And that gambrel then means that we actually get a lot of height. So our buoyancy driven ventilation is excellent with that design, as long as we have ridge opening at the top. I said that height difference between inlet and outlet is really important, and the gambrel gives us quite a bit of it. That's why we see a lot of older barns from the 1800s had that style of roof. It created a lot of airflow in that space, and also a lot of extra air space above the animals. I will say that if you are worried about heat in the wintertime and spaces being cold, it can also push a lot of heat up into the top part. And if you don't have any way to bring some of that heat back down, you can exhaust almost all of your heat out of the barn that way as well. So you can actually create a lot of air movement in those barns, but it can be challenging. The gambrel style barns, at least the older ones that I've seen, don't always have great openings for windward air movement though. So you do want to make sure that you do have some openings for summer air movement, windward air movement.
So it's one of those, it depends.
It depends, exactly. It absolutely depends. And it's a little bit personal preference. And it's also how it was designed and how it's laid out. But both of them will work fine under the right conditions. You just want to make sure that openings are in the right spot and they're the right size.
Okay. Kim wants to know, is there a certain amount of ventilation per square foot that I should have, or how do I know I have enough?
It's actually not on a per square foot basis. We typically do our ventilation design based upon animal head, number of chickens, and technically it's based upon the weight of the chickens that are in the space or any other poultry that would be in the space. I would tell you that yes, we could calculate it and absolutely we can, but you're not going to be able to measure it, which makes it even trickier. So I would say that the things you should be looking at that would be indicators of not having enough ventilation are condensation. If you have any metal inside the structure, if you're getting a lot of condensation on metal, that's a good indication. And if you're getting it on wood surfaces, that's definitely an indication that you have more moisture in there than you should in the wintertime. And if your temperature inside the barn with the animals in there has risen, say, more than maybe 6 or 7 degrees Fahrenheit from the outside temperature, it probably means that you don't have enough ventilation in the summertime. You're getting too much heat load in there in the summertime. There are ways that we can create openings to make it cooler in the summertime. That sounds kind of weird, but those are two of the major indications that we have ventilation problems. Also, there's this dynamic with dust and ammonia that's usually another indicator. So if we have a lot of ammonia, that means we have moisture problems, which means we probably have under ventilation. That's a little bit also the manure management strategy that people are using. So people can have too little ventilation and no ammonia problems, and good ventilation and some ammonia based upon how they manage manure. But generally, if we have a lot of ammonia, that's also an indicator that our ventilation is not being managed correctly.
How high should the pop-outs be from the ground?
Off of the ground or
It says from the ground.
from the ground?
So those ones where you had the pop-outs on the walls, how far off the ground should it be?
I mean, it depends on the size and type of bird.
Broilers aren't going to go very far, whereas layers might.
Right. So
Bantams would be different than standard.
Absolutely. I guess what I would say is the pop outs, what you don't want is that bottom plate, that wood plate, to be in contact with a lot of manure or soil. So if you have a building and you actually have like some concrete foundation around it, your pop outs can be very close to the ground without any real issue. The other thing you can do is you can put your pop outs at the ground level and then place your perches up higher. And that way, even if you have pop outs open and you want animals out of that draft, they can then jump up onto a perch and move themselves out of the drafted area. So there are strategies to have pop outs and still have animals able to move out of drafted areas.
Clarification is it in regards to ventilation to keep from drafting?
So what I would say is I'd move the pop out where it needs to be for the animals to safely not injure themselves getting in and out through the pop out. What I would probably do is limit the number of pop outs I had open on very cold days. So if I had 3 pop outs on each side and it's really cold, I might only open 1 on each side, or maybe 1 on one side and 2 on the other on the non-windward side. Or I would open them all on the non-windward side so that I don't have a lot of air drafting in and I just force the animals to go out wherever I didn't have a lot of wind blowing in. And then I would still probably use that recommendation about creating perch areas that are a little bit higher above the pop out so that they can move out of that opening, so that they don't get drafted necessarily on the ground when they're open and it's really cold.
If you have pop-outs on both sides, should they be opposite each other or offset?
I'd probably put them opposite each other just because that's usually structurally easier to do, just the way that post spacings work. And then if you did want them both open in the summertime to get some cross ventilation, great. But you might want to then, alternate what was open in the wintertime so it couldn't draft across.
Right. Okay, are there any more questions? We still have a few more minutes. I didn't see any more. I put in the chat box where the recordings from past webinars and where the information is for upcoming webinars. Our next webinar is May 3rd on controlling internal parasites of poultry, always at 3 p.m. Eastern time. So I don't know what zone you're in. If you have any topics that you're not seeing a recording for, email me and we'll start putting something together. Always looking for additional topics. We want to meet the needs. This was one that people asked for. So great job, Morgan. You did as usual, a good job. Hopefully anyone who's thinking about looking at retrofitting a building got some things to think about before they go at it and start putting birds in. Start thinking about it before you put the birds in. Okay, I'm gonna stop the recording.